Hello, everyone, and welcome to my class. Today we will be talking about, you will be learning, I will be doing the talking. We're going to be learning about algebra problems again. Well, mostly factoring. Well, not basic, not basic factoring. It's a bit more complicated factoring. All right, so let me share my screen. Tell me if you can see my screen or not. Okay. Can you see my screen? Say yes in the chat if you can see my screen. If you can't, then say no. Okay, very good. Yes. Are there any issues for anyone? Any issues? No? Okay, so if you have any issues with seeing my screen, then just put it in the chat. Okay, let's begin. So our schedule today is factoring and distributive property, and then we're going to do sum and difference of cubes. And then, well, in addition to sum and difference of cubes, we're going to be learning or reviewing some useful formulas like difference of squares and that kind of stuff. And also, we're going to learn a faster method of factoring. All right, so let's start off with an example. This example, basically, you're going to multiply these two terms together, and you're going to simplify the terms, combine like terms, and then you're going to have an answer. All right, so please start doing this example, and then I'll show you the faster way to do it, in addition to like the traditional way where you use distributive property to multiply every term. So once you're done multiplying, you should get 9 terms, because every one of these terms, okay, multiply, and 3 as well, okay. So that's basically what you're going to do. You're going to use distributive property to multiply all the terms together, and then you're going to get like 9 terms, and then you can combine like terms and simplify. All right. Please start doing this problem, and once you are done, you can post your answer in the chat box. And I expect everyone to try at least, and even if you're afraid your answer will be wrong, please put it in the chat box. I want everybody to be answering this, or at least trying to do it on their own. So if you still haven't gotten out your scrap piece of paper, this would be a good time to do that. So, all right. I'll give you a couple moments to... Oh, Steven joined. You're late, Steven. Anyways, for those who just joined, we're doing this example, so once you're done, post your answer in the chat. Okay, I'll give you a few moments to try and solve this. I'll erase this in case you have trouble seeing it. Okay, I'll check back in a couple moments. Okay, we have one answer already. Wow. Okay, Stephen. Let's see about that. Let's see. You forgot to simplify. Okay, then simplify first. Okay, 84 times 2. Oh wait, 84x to the second. Okay. 84x to the second. Alright. Ooh. 6x to the fifth minus 12x to the fourth plus 5x to the third plus 22x squared minus 34x plus 21. Alright. We've got 3 answers already. I'll put back the slide. If you have any more answers, here's the time to post them in the chat box. All right. I'll give you a couple more moments to work on it. If not, then I'll walk you through the problem. Okay. 2 more answers, I hope. Maggie and Stephen. All right. Yes. Are you sure about that, Stephen? First part is correct. 6x to the fifth minus 16x to the third. Huh. Where did that x to the fourth go? Ran away, huh? All right. Edward is correct. Congratulations to Edward. And Maggie is also correct. And Stephen is close. Okay, well, good effort to everyone who tried. To those who didn't try, well, you make you miss 100% of the shots you don't take. So too bad. Was that quote correct? I've, it's tiring to act cool. Okay, pretty sure that quote was correct. I read it somewhere, I think. Okay, let's just, yeah. All right, so distributive property. Basically, you're going to multiply 2x squared to 3x to the third, negative 2x plus 7, okay? And then you're going to go back and do the same thing with negative 4x. You're going to multiply, okay? It's a lot of multiplying, all right? So let's do that. Okay, so 6x to the fifth, you're just going to multiply them. And remember, when you're multiplying exponents with the same base, add the exponents. So let's do that. Okay, negative 4x squared, no, to the third, plus 14x squared minus 12x to the fourth, plus 8x squared minus 28x. All right, plus 9x to the third minus 6x plus 21. Okay, so after we're done with that, you're just going to combine like terms, all right? So 6x to the fifth is the only x to the fifth, so let's just do that, okay? And then we only have this x to the fourth, so we're just going to keep that as well. Okay, and then we have two, two x to the third. So basically, it's going to be plus 5x to the third. Okay, they cancel out. And then 9 minus 4, right? It's 5. And then add, you're going to add x squared, right? 14 plus 8 be 22x squared. And then minus 34x. Okay, minus 34x, where x terms right here. Okay, minus 34 plus 21. So basically, that's your answer. Very long answer. So congratulations to people that got it correct, and good efforts to everyone that tried. Okay. So are there any questions on this method? Any questions? Say yes if you have any questions. Say no if you don't have any questions. Okay. So I'm assuming no one has any questions, right? All right. So who agrees that method was kind of too long, right? It was too long. So what is this? Slow. Yes. It was very slow. Yeah, that method was very slow. So what you need to do is I'm going to introduce a new method, all right? And I mean, this is fine when you have like 3 terms times 3 terms, but what if you have 5 terms? 5 terms times 5 terms. That's going to be 25 terms that you're going to have to combine like terms, and then there's going to be a lot of mistakes when you get to that point. And then what if you have 6 terms? It's going to be 36 terms all together, and then combine like terms. Okay, it's not very efficient, so I'm going to show you another method. What the heck is this? That's correct, Cindy. However, you need to put the x to the 5th first, because the highest exponent goes first. So good job, Cindy. But next time, like kind of rephrase your answer. No, it's fine. It's fine. Okay. Anyways, that was the correct answer. So it's just, the standard way is to put the exponents first. So, but good job. Okay. So I think someone joined again. Well, anyways, if I don't know who you are, so many participants. 13 other people. I don't remember their names. So if whoever just joined, I'm famous now. Just 13 people joined my. So okay, 14 participants isn't that bad. I mean, compared to what I did like last few lessons, literally like 10 people joined. But I used to have like 35 participants in my last class, like 5th to 6th grade. I mean, the stuff was easier so people could understand. And then this is kind of hard, so people don't understand, so they leave. All right, let's do this. Okay, so the faster method. All right, it's a new method. Okay, new method. Okay, this new method, basically, I just copied this same problem here. So let's see if we get the same result with this new method. Basically, we're gonna look at this first. Okay, so basically we're going to use standard algorithm. 60, 54 times 35. Okay, times. Okay, sad. This is very sad. Okay, and then you do 5 times 4. Okay, 5 times 5, and then you add. Standard algorithm. Very, very, very standard, of course. Yeah. So basically what you're going to do is you're going to create some columns for x to the third, x to the second, x, and 1. Okay, so basically these are columns. So let's look at this set of parentheses first. Okay, so how many terms are x to the third? There's 3 terms. How many terms are x to the second? 0. How many terms are x? -2. How many terms are 1? 7. Same thing with the next one. No terms in x to the third, so don't need to do that. And then for x to the second, there's 2 terms, -4, and then 3, right? So let's do the same thing with standard algorithm. So multiply these. What is this? 21. Okay, what is this? Multiply 3 and -2, -6. 3 and 0, 0. 3 and 3, 9. Okay, and then the second column, basically -4 times everything. And you see x, because you see 1, because 3 is in the 1 category, so 1 times anything, the result still stays in its own column. However, if we're multiplying x and something, then everything is going to go up a column. For example, 7 right now is going to be multiplied by -4. But since -4 is in the x column, then the result will be one thing higher, right? 1 column higher. So you're going to put -28 in the x column. Because what you're really doing is you're doing -4x times 7, right? -4x times 7. So it's going to be in the x column. And then let's do everything the same. It's going to be 8 here, okay, and 0 here, and then -12. What is -12, right? -4x times 3x to the third, that's going to be x to the fourth. So let's make a new column, I guess. And then you're moving on to 2, and that's in the x squared column. So everything goes up 2 columns. So 2 times 7, that's going to be 14. 2 times -4, okay. 2 times -2 is -4, and then 0, and then 6. Okay, same thing. And then you're just gonna add, right? You're just gonna add. So, and then when you're adding, this is x to the 5th column. Basically, after the result, write x to the 5th, or whatever column it is. Okay, so -2x to the 4th. Okay, plus 5x to the 3rd. Plus 22x squared. Okay, minus 34x plus 21, right? Okay, it's that easy. So we got the exact same solution, but it was much quicker and, well, if I didn't explain that much, it would be way quicker than what we just did. Well, since it's like 3 terms times 3 terms, it's not that hard to combine like terms and do this. But if you had 5 terms and 5 terms, then this would be the method you would use, especially if you're going to a math competition and you want to be fast. And also, you make less mistakes with this. So, of course, you're eating again, Carney. If there are two variables, okay. Let's see, 2 variables. That's interesting. So basically, 2 variables. How would you do that? Well, I don't think that would work if you had 2 variables, because since this is all ordered, with x to the 3rd and x to the 2nd and x to the 1st, it's all ordered, like 1x, x squared, x to the 3rd, x to the 4th. But if you have 2 variables, then you could do x to the 3rd, y to the 3rd, x to the second, y to the second, and that kind of messes up the order of it all. I don't know. I've never actually wondered about whether it could do two variables or not. I don't know, actually. But I don't think that would work. Well, with variables, two variables, yes, of course. You have to do the slow way. Yeah, of course. Okay, so now let's go on to useful formulas. All right, so before I go on, does anybody have any 15 participants now? Who just joined? Joined in the middle of class. Oh, okay, I don't even know who joined. I'm famous now. There's only like 14 participants. I'm not that famous. But it does feel good. You have to scroll down to look at all the participants. It's a good feeling. It's a good feeling. Even if I only need to scroll like 1 inch, but good feeling. Yes. Yes, of course, not specifically really famous, but at least I'm not bad. Kind of. Okay. Wait, I have 40 subs now. Oh, I never even checked. Too bad. Okay, so useful formulas. Let's move on. Who knows what this equals? Right? X plus y, x minus y. What does this equal? What does this equal? And what is this called? Right. X squared minus y squared. Yeah. I stopped uploading since 1960. It's actually a little bit before that. Yes, of course. Good for you. 7 subs. Yeah. Okay. Okay, so this is called difference of squares. You see, when you multiply it out, you get x squared plus xy minus xy plus y squared. So, actually minus y squared minus y squared. So these cancel out and you're stuck with x squared minus y squared. So if you have like what, 81x squared minus 16y squared, then it's going to be what, 9x plus 4y, 9x minus 4y. Okay, so it's kind of useful in that way when you're solving and simplifying and stuff. And then we also have x plus y to the second, which is x squared plus 2xy plus y squared. Okay, and this is also very useful when you're factoring and solving equations, and staying with its opposite, x squared minus 2xy plus y squared. Okay. And also we have, this is a bit harder, but we also have x plus y to the third. Okay, that's basically x cubed plus 3x squared y plus 3xy squared plus y cubed. And it also works for minus. Just add a minus sign, plus minus, and you're going to change the first and the last plus sign. Okay, so it depends. And there's also like x plus y to the fourth, but that's pretty complicated, so I'm not going to explain that yet, but if you want me to, then I can write it out. But basically, it's x to the fourth plus 4x to the third times y plus 6x squared y squared plus, wait, no, that's a 4. 4xy cubed, okay, plus y to the fourth. Okay, pretty complicated. And this formula is actually derived from the Pascal's triangle. And you see here, basically, what do we have, right? What do we have here? Let me write out a basic Pascal's triangle here. So what we have here is extremely similar to Pascal's triangle. All right, this is Pascal's triangle, okay? Mathematician, okay? And he made this formula to get all these x plus y to the fourth and x plus y to the fifth. And this is Pascal's triangle. And you might have heard of it, but you might not have seen what oh. What is this? Okay, yeah. There's also some indifference of cubes. Yes, Stephen, there's also. Actually, I'm going to talk about that on the next slide, so. Yes, okay. And of course, you guys are chatting away and in the chat, of course. Yeah. Okay, so Pascal's triangle. You look at this. Very seems very similar, right? Because the difference of square. What is difference of square? That's x squared minus y squared. 1 minus 1. It's the first level. And then what do you have? What you have, okay, is 1, 2, 1. 1, 2, 1 is this. X squared plus y squared, where x squared and y squared are 1, and then 2xy is 2. What about cubed? Okay, cubed is what? The third level. Okay, you have 1, which is just x to the cube, x cubed, and then you have 3x squared y plus 3xy squared plus 1 again, which is y cubed. Okay, see a pattern here. And then x plus y to the fourth, that's going to be x to the fourth, which is just 1. Okay, 4, 6, 4, 1. Okay, 4, 6, 4, 1. Okay, so there's a pattern here. And if you need to find out what the fifth is, I mean, you can just continue the triangle, right? I mean, right? Okay, let's see what we have here. 10, 5, 1. Okay, that's what we get, right? I think so. I don't know. Okay, so now let's move on to some indifference of cubes. Now x plus y to the fourth, maybe you use that a little bit, but x to plus y to the fifth, probably you're not going to directly just multiply that out, because that would be very bothersome. Okay. All right. Now 16 participants. When did I get so famous? That's like +3 participants from last time. So good. Okay, so some indifference of cubes. This is also extremely important. And whenever you're simplifying things, it would be very, very important to have this. All right. So after this, if you're not familiar with these formulas, I'm gonna use some examples. Okay. And hopefully you'll understand more once you solve these examples. So I hope everybody is taking notes so far. If you need to stop, if you need me to stop so you can take notes, you can feel free to put that in the chat. But now I'm going to move on to sum and difference of cubes. All right, so x to the third plus y to the third, or x cubed plus y cubed. This is sum of cubes. And what that equals is, you gotta be kidding me. Why did I take a screenshot? I didn't even try. There goes another screenshot. Okay, so basically, it's going to be x plus y, x squared minus xy plus y squared. All right, so that is what sum of cubes is. That is the formula for sum of cubes. And this will be incredibly important when you're simplifying or factoring. Okay, and if you want to multiply it out, it's going to be the same result. So x to the third, let's multiply it out actually and prove it. Okay, so x to the third minus, okay, what is this? Minus x squared y, okay, plus xy squared, okay, plus, what is this? Squared, okay, and then minus xy squared, and then plus y cubed. All right, so basically you see here, it just cancels itself out a lot, right? And then, wait a second. Hold on. It does cancel itself out. Oh wait, I got this one incorrect. Hold on. This one is supposed to be x squared y. Okay, so now it cancels itself out. Everything cancels out, and then you get x cubed plus y cubed. And the difference of cubes is very similar to this. It's x minus y times x squared plus xy plus y squared. And you can just, if you want to see if that really works, you can just multiply it out like it did. And it's important to memorize this little trick. If it's sum, then this will be an adding sign, x plus y, and then this will be a minus sign. Okay. If it's difference, then this will be a minus sign, this will be a plus. Okay. Are there any questions? Okay. Yes. I'll go back to the useful formula slide. Let me erase this Pascal's triangle. It's a bit too, it's blocking some of the stuff, so, and get rid of this. All right. If anybody else wants to take notes on this, you can. What the heck just happened? Okay, so I finished erasing everything. All right. Okay, are you done taking notes? Are you? If you're done taking notes, you can let me know. All right. So, hold on a second. I just noticed that I've spent like 40 minutes, or well, about 30 minutes just talking about like 5 slides. Oh, that's sad. No, 6 slides now. All right, so let's, what am I talking about? New way of, oh wait. Oh, new way of factoring. That's pretty important. Need to get to that. Okay, so does anybody know? Oh, all right. Hold on. Chat. Okay, not yet. Okay, let me go back. Well, if you're really desperate, you can go up to Google and check these. But yeah. Okay, you're done. Okay, I'll just hold on. Yep. So examples: sum and difference of cubes. Oh wait, no. This is difference of squares. That's sad. All right, this example is pretty easy, so I'm gonna do it for you. And basically, it's 5x plus 7y, 5x minus 7y. That's too easy. Let me go on to something harder. All right, let's do this. This is sum of cubes. So how are you going to do this? Use the formulas I just gave you. Okay, so x minus plus y, x squared minus xy plus y squared. That equals x x cubed plus y cubed. That's sum of cubes. So please use that to simplify this and factor it. Once you're done, you can post it in the chat box. Hold on. Yeah. Okay. Okay. Any answers? All right. I'll give you a few more moments to do this. Use sum of cubes. Sum of cubes. Okay. We have one answer. Hopefully, it's an answer. Great. Edward. A plus 4b squared times a squared minus 4ab squared plus 16b to the fourth. Are there any other answers? Okay. All right. That's good. Edward, you are correct. Very good. Now, if you don't know, because I think a lot of people got confused because it's like b to the sixth, right? But what is b to the sixth exactly? It is b squared to the third, right? That's what it is. So it's basically a cubed plus 4b squared cubed. That's what this is. Okay? And they're going to take x, and you're going to take y and just plug it into the formula. And then you get what Edward got. You're going to get a plus 4b squared, because x plus y, and then x squared, which is squared, plus 4ab squared plus 16b to the fourth. All right, so that's your answer. So now for our last example. And all right, I'll give you a couple moments to do this. Okay, so I'll give you a few moments to do this. And meanwhile, I'm just gonna chill on the couch. So, you know. Okay, one answer. No, I'm not in my living room. I'm in my room, and then I'm going downstairs to chill on the couch and then coming back up. No, just kidding. There's a couch in the upstairs. Okay. X minus y. What? Your final answer is x minus y? All right. Well, answers come in all sorts of shapes and sizes. All right. Steven, are you letting Edward beat you again? Where did Steven even go? Did he leave? No, he didn't. Upstairs. A coat. Well, it's like a sofa. It's small. You can seat like 2 to 3 people. Oh, 2 people if they're fat, 3 people if they're skinny. Okay. So, what type of Taco Bell did you eat? How did you know he was doing number 2? Oops, sorry, I was in the bathroom. Okay, so what is this? Hold on, x minus y. Excuse me. Are you sure about that? Come on. There's still more, Edward. There's still more. What? Yes, of course, it's 1 hour long. All right, so x cubed plus y cubed. Of course, you can simplify that. I'm ready to clobber Edward. All right. Take your hammer and clobber Edward. Okay, clobber him. Clobber him. Take a sledgehammer. Yes, of course. Okay, this is too much. I need to do this new factoring method and I don't think I'll have enough time, people. All right, I'm just gonna do that next class. So clobber Edward. Steven, clobber him. Bonk. I don't think that's the sound. I don't think that's the sound when you clobber someone. That's basically hitting someone with a baby hammer. I think there won't be any sound if you clobber someone with the big sledgehammer. Excuse me, what is this? Oh wait, that's correct. Well, Edward just got clobbered, so because Edward got the incorrect answer. It's so bad. Come on, Edward. You can still simplify x to the cubed plus y cubed. It's not that hard. Yes. Of course. Crack. I don't think only the skull was going to be cracked if you clobber someone with a sledgehammer. But okay. So, how are we going to do this one? X to alright, so basically what you need to do is you're going to what if we did okay, so basically some people get the incorrect answer because of this. They do this first. Why is this incorrect? Alright, it's fine, it's acceptable, right? It's acceptable. Well, you're going to get x squared minus y squared times x to the fourth plus what is this? Plus x squared y squared plus y to the fourth. It's acceptable. And then you can simplify this. Right. It's a good answer. Right? You can do it. However, you can simplify even further if you take another route. Okay. That is if you use difference of squares first. So basically, you're going to have x to the third squared minus y to the third squared, which equals x to the third plus y to the third times x to the third minus, hold on, minus y to the third, and that's going to be x plus y, x minus y, x squared plus xy plus y squared, x squared minus xy plus y squared. All right. So that's what you get. Okay. We're done here. Yes, we're done. So that's how you simplify. All right. So what do you guys want to do next? Do you want to leave class early or leave class early? All right. All right. I mean, we have to learn this new way of factoring. I don't think we're going to fit all these examples with this in this lesson, so I'm just going to do that next time. So, all right, yes, teachers call up the ear. What is this? What happened? What is this? Stupid. Okay. Yes, of course. I'm the same age as you, Edward. So of course you feel stupid. You're gonna feel even more stupid because Steven is in 4th grade and he just clobbered you with a tree. Yes. You have some affairs. What kind of affairs? You have to. You feel like you're the only one IQ person here. Last strike up someone's head. All right, just chat. Okay, well, you guys chat. I'm just gonna. Bye. All right. Okay, I'm just gonna let you guys leave class early.